So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address, or that is, we are actually creating switch hardware switch. Well, the difference is that in soft switch, the implementation itself is done at this one, port 2, port 3. You all belong to a soft switch that we will name it. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic decisions are made by the physical switch itself, it's hardware virtual switch. We'll see that virtual switch, let's call it marketing. And now let's configure the different ports, 4 and let's use internal 6. All right, switch. And let's see if we have virtual IP address. It's management. Let's use LAN2 as our alias, and let's get him an IP address, and that's right. I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. Let me show you the best user setting tips for your Fortigate, and we start right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have your users connected to one of the interfaces in your Fortigate and you want to set up different settings as authentication timeout and so on. So head over to the command line, config user settings, and the first command is set auto timeout. Let's move over between the different options, and there you can choose different integers from 1 minute up to 24 hours. Now the default is 5 minutes. Personally, I prefer to set the timeout to 30 minutes. So choose whatever suits you as an administrator and your company's policy. The second command is quite important. Set auto timeout type. Now there are different types of authentication timeout. There's the idle timeout, the hard timeout, and the new session timeout. What is the difference? In an idle timeout, Fortigate has to see traffic that is coming from the user. If it doesn't see traffic coming from the user's IP address for the time we configured as the authentication timeout, well, it deletes the authentication entry and asks the user to authenticate again. Now, in a hard timeout, it doesn't matter if there is a traffic or not. After the authentication timeout passed, the user will be asked to authenticate again. That's a hard timeout. The last option, new session timeout. Well, that's the case where you have a timeout. Let's say it's 5 minutes. You head over to a site, you start to download a file. Now, after 5 minutes, the file download is not terminated. It still goes up and downloads to your computer. But if you head over to another site, that is, you create a new session, you will be asked to authenticate. Another option that every administrator needs to configure is the amount of failed attempts before the user is being blocked. That is the number of time a user can fail authentication until it is being blocked. Now the default is currently 5. You can change it up to 100 times. I usually use 3 times. So that is set auth invalid maximum, that is the maximum number of invalid login attempts, and let's set it to 3. Some of your user will probably head over through a captive portal, that is outsource employees and so on. So you can set the set auto portal timeout. That is the amount of time that those employees will need to authenticate again to an integer of between 1 up to 30 minutes. One of the key elements of any authentication scheme is the usage of passwords. We use passwords all over in our Fortigate. We use it when we configure new users. We use it when we configure our admin profiles. We also use it when we configure SSL or IPsec VPNs. We use passwords all over. We will look at password entropy, how random or how difficult it is to predict your password. Let's start. So an entropy in plain words is the difficulty in guessing a password either in a brute force attack or a dictionary attack. Now, how do you calculate entropy? Well, you do it using the length of your password, the complexity of your password. Are you using uppercase characters, lowercase, or maybe you're using uppercase and lowercase? Are you using symbols? Are you using numbers? The more complex your password is, there is much more entropy. And the last parameter is the randomness of your password. The more random it is, it adds up more entropy. Now, randomness is an issue when it comes to computers, since computers can actually generate a pseudo-random numbers. All right, so let's look at an entropy example and things will be much more clearer. So we are calculating entropy using the following formula. H equals L. L is the length of your password. H is the total binary bits of an entropy. Entropy is calculated using bits. And N is the number of possible symbols in a password. So a password length of 8 characters from the entire alphabet, that is uppercase, lowercase, symbols, and numbers, will get us to an entropy of 2 to the 52. So this password has about 52 bits of entropy, and it is a strong password. The higher your password entropy, the less predictable your password patterns are for a computer. As far as password, 36, 37 bits of entropy are rather good. Another example is when we use a keylock that has only 10 digits, that is 0 to 9. So if we use only 5 characters, you know what? If we use 4 characters, we usually use 4 characters as our passwords in a panlock keypad. So that is 10 to the power of 4. 10 to the power of 4 is 10,000. So the key space of the password is 10,000 passwords. If we use 5 characters, out of the 10 digits, it is 10 to the power of 5, which is only 100,000 passwords, and the entropy is only 16 bits. So this is not a good password in the digital world. It may be a good one in the physical world. If we use only lower letters in the English alphabet, we have 26 letters in the English alphabet, and we use a password of 7 characters. That is 26 to the power of 7. It gets us to a total of 8.3 billion passwords. The entropy there is 32 bits only, so still it is not a good password. If we use 8 characters out of the 26, that is 26 to the power of 8, we have 208 billion possibilities. That's the key space. The entropy is 37, which is quite good, though nowadays we use passwords with more complexity, that is using the uppercase and the lowercase plus numbers and symbols. We can use the command line to diagnose and learn more of our SD-WAN member interface. Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. We can use our command line while configuring SD-WAN for different tasks. One of them is to use different protocols that will be used towards the server that was chosen in the health check. So if we look at the performance SLA, let's choose one. And we can see that on the graphical user interface, we only have two options to ping our server, that is using ping and HTTP. Now, if we will use the command line, config sys virtual WAN link, config health check. Now let's edit the performance SLA that we have chosen, that is SIP. Let's see what is chosen. Show full configuration, and we can see that the protocol that was chosen is ping. Let's set protocol, and now you can see that we have the ping option, the TCP echo option, the UDP echo option, HTTP, and TWAMP. So that is something that is available on the command line and not on the GUI interface. Another thing that we can do or actually see using our command line, let's use the diag sys virtual WAN link. Let's choose the SIP. Can't see it that way. Let's choose the SIP health check. Now we can see the status of each member in our SD-WAN, in our virtual SD-WAN interface. In terms of packet loss, we can also see it on the graphical user interface, but that is also one way to look at the different members. We can see that it is alive. We can see that we have no issues currently with packet loss. And we can see the statistics for latency and jitter. Currently, the other members are not alive since I have not enabled them on my Fortigate. Now, whenever we use performance SLA, we are actually telling our Fortigate to probe different services. We can configure up to 2 servers that will be used as beacons. We are doing that to check the status, the health of the different members of the SD-WAN interface. Now, whenever our Fortigate probes that server, it is actually using a route entry that is created. Let's see that route entry. So we will use the get router info kernel, and those entries are actually flagged. They are created in the kernel. They are called fib entries, and they are flagged as proto 17. So to see them, we will use the grep command, and we will use the proto equals 17, and we can see, let's make that a bit bigger. We can see the different routes. They are being sent from the different interface gateway towards the different servers that we have chosen. The first one was actually the Google DNS server, which is 8888, and the second one is 1111. Hey everyone, so here we are at part 4 of certificate operations in your Fortigate. This video series spreads some light on the importance of certificates and why do we use them. It is not a tutorial of how to create a self-signed certificate. We will get to that. It is actually the theory behind digital certificates. So what did we have? We had symmetric encryption, where the two parties share the same secret key. We also learned of asymmetric encryptions, where we use a key pair, a public and a private key, different keys yet related mathematically. And then we had, at part 3, we had hash functions, a one-way function that takes any input and transform it into a digest, a hash value that is not reversible and is collision-free. That is, no two different inputs can produce the same hash value. Alright, so let's connect the dots. A CA, which is a certificate authority, issues digital certificate. This digital certificate also contains the public key of the entity who requested the digital certificate. It can be just about any web server out there. Another thing that it does is signing the digital certificate. How it does so? It hashes the digital certificate along with the public key and then encrypts it using its private key, using the CA's private key. Now, when a browser connects to a secure web server, it gets the certificate along with a digital signature. Think about it as two different files. It opens the digital signature using the public key of the CA. It has the public key of the CA in its certificate root directory. Now, any browser keeps its certificates, its CA certificates, in a different place. Now, as the file is being decrypted, he gets the hash of the digital certificate value. He then takes the digital certificate, the original one, hashes it using the same hash algorithm that was used by the CA. The type of the algorithm is also present on the certificate itself. We can see it right here. If both hash values are the same, then we have a proof that the entity who sent the certificate is the one who it claims to be. So we have used asymmetric encryption and hash functions to prove the authenticity of the entity. Now, the two parties, the browser and the web server, will negotiate the symmetric encryption that will be used as the encryption algorithm, the cipher itself, to encrypt the communication between them. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the topmost CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the diag-systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, the new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. So your access points have been deployed. How can you limit the amount of clients that will connect to your access point, to a specific access point? Client limitation is crucial whenever you have high density deployments and you want your clients to move between access points whenever there is a good signal strength between them and an adjacent access point. Well, you can limit the threshold, you can limit the amount of clients. It can be 10, 20, 30 clients per access point. But you can also control the threshold, the load balancing threshold. So whenever a client has enough signal strength to another access point, it will roam to that access point. Let's see how we do it. All right, so let's use our command line to enable the access point handoff, to limit the number of clients to that access point, and to configure a threshold. So let's configure the wireless controller WTP profile. There it is. And let's use one of the default profiles, which is the 11N only. Let's configure the radio. And let's set the access point handoff to enable. All right. And now let's move back and configure the handoff station threshold and limit it to only 15 clients. So only 15 clients will connect to that access point before the load balancing mechanism will start to work. And the last thing to do is to set the handoff RSSI. And let's use a handoff RSSI of 30. Now, in the case where our clients will try to connect to our access point, the controller, our Fortigate that serves as a controller, will signal the client to connect to another access point. One of the key topics that you will master using your Fortigate firewall is policies. So, what is a policy? Why do we need policies? And how do we configure policies? Well, a policy is a rule that when a traffic flows from one interface to the other, it matches different patterns of the traffic. It matches the interface that the traffic comes from, the destination interface that the traffic is heading towards. It also matches the source of the traffic, its IP address, if it belongs to a user or a user group. If it belongs to a specific device, it can be a PC, it can be a smartphone. And when done, when traffic matches your rules, your specific patterns, then the policy takes the security profiles action, which is an intensive process that looks into the payload itself and looks for different patterns to identify the traffic, to look for viruses, to look for anomalies. We will look at IPS and antivirus later on. And then, when all goes well, the policy decides whether to NAT the traffic and whether to log it. Policy is actually a three-step procedure. Let's look at a very simple policy. We will create one now. Now, on our policy, the first part is the part where we look for matching traffic. Let's name our policy. Let's call it full access. And let's decide that we wish to allow any user that sits on a specific LAN. It can be your marketing division LAN, it can be your finance LAN. Each LAN will probably have a different subnet to get out to the internet over the outgoing interface, which is our WAN interface. Our WAN interface is the interface that is connected to our ISP. Now, in terms of source, we will allow any source to get out to the internet. We can also limit it to specific users or different user group. We can create a user or a user group using the plus sign. We can also limit the traffic to a specific device. So if we, for example, want only Linux devices to get out to the internet, we can limit it to a Linux PC. Now, we will not do it. As for destination, we are not limiting. We will let anyone get out to any destination, but we can limit the destination towards a specific address. As for scheduling, we can limit our policy to work on a specific day, on a specific hour, but we will not do it. Anyone can get out to the internet always. And the last part of the first step in our policy procedure is this service. We can limit this service to be HTTP, HTTPS, or any other service, any other protocol that we wish to limit our users, but we will not do it. Users can use just about any protocol, any service. And then we decide on the action. Are we accepting the traffic? Are we denying it? Or maybe we are using it as a learn policy. A learn policy is a very specific policy that actually triggers security profiles beneath that no one really knows that it's there, and it learns our traffic and creates a report that we can look into and see users' traffic, most used applications, threats, and so on. The second part is the UTM profiles. We can initiate any UTM profile, any security profile on our policy. And the third part is whether we are enabling NAT. We have seen how NAT works using a NAT overload, IP pools, or maybe central NAT. And then we decide whether we want our policy to be logged with log all sessions or only security events. That's the basics of a simple full access policy. If you enabled Web Application Firewall on your Fortigate, then you need to know of XSS, cross-site scripting, one of the most known and malicious attacks on web servers. More on XSS coming right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When you think of web apps, any web app, in its basic, it is built around three components. That's the very basic. There's HTML, the markup language. There's the programming language which adds interactivity into the page itself. We usually use JavaScript. And there's the CSS, which is responsible for the styling. Now, think of a web app that when a user enters an input into one of the forms fields or any place that a user input is needed, it doesn't sanitize between a pure data that is text, and a malicious code. Malicious attackers use XSS for different reasons. It can be a harmful reason, such as changing the look and feel of the web app, its background image, or color or type of font, but it can also be used to steal cookies from the user, to grab screenshots of its computer, or to even insert a keylogger that will send any keystroke to a specific URL. There are actually two types of XSS attacks. The first one is reflected XSS. That is XSS attack or malicious script that is reflected on the victim's browser. And the second one is stored XSS, which is the malicious code that is stored in the web app database and is executed every time when the user calls the specific function. Now, what can you do with XSS? Well, just about anything. If you head over to XSS payloads, you can find out different JavaScript payloads that can be inserted as a malicious code on a web app field or form and can be used to capture keystrokes, can be used to take screenshots out of your screen, or even grab images from your webcam. So XSS is pure evil when it is used in the hands of the wrong man. Let's look at how the JavaScript itself looks like. So that's the JavaScript itself. Now, in most of the cases, the JavaScript code also takes the information that it grabs. It can be a screenshot from your computer or even your cookies that are being stolen and sends it to the attacker URL where they can grab it and use it against you. One very known attack is when you use XSS to steal some other user's cookies and then you head over to the same website and pretend to be that user. Five best tips for using your antivirus within your Fortigate. The first one, choose whether to use it in a flow-based mode or a proxy-based mode. You can see that in a flow-based mode, the features are quite limited, but moving into a proxy-based mode, you can see that you have much more options when using antivirus. The second tip, choose your database. There are actually three main databases that you can use within your Fortigate. There's a fourth one, which is a compact database, but you can use the config antivirus settings and set the different database. You can use the default database, the extended database, and in specific Fortigate modules, there's also the extreme database, which actually includes just about any signature. Our third tip is use grayware and heuristics. Now, when you scan using antivirus, the first step is to look for known signatures. The second step is to look for grayware. Grayware is not by definition a malware. It is an unsolicited program that usually downloads to your computer without you ever knowing about it. A good example is an adware. So how do you enable grayware? Again, config antivirus settings, set grayware. Now you can enable or disable. My tip, always make grayware enable. Alright, now for the fourth tip, use heuristics. Now what is heuristic? Heuristics, let's just, alright, let's config antivirus, but this time not settings, but heuristics. Now heuristics is actually an analysis of behavior, the way a file behaves. Now, Fortigate looks for different patterns, and if the file behaves in a suspicious way,